So yeah, I'm going to talk about a vision for scalable oversight. This is our team. Some of them are here today as well. Rory and Tian, I've seen, and Rohin, you would have seen earlier. I think Noah is here as well. Yeah, and a disclaimer that this talk does not necessarily reflect an official stance for DeepMind. I was speaking more about personal opinions and a vision, really. So I'll start with the takeaway in case you turn off throughout. So here in this talk, I'm trying to give some opinions on some useful ingredients for scalable oversight. Some of these ingredients include iteratively using trusted current generation models to train the next generation model, developing games with incentives for decomposing hard to verify responses into easier to verify responses, and techniques that additionally improve legibility of responses and the robustness of verification. So I'll kind of talk about these in the abstract a bit, and then after that I'll give an example approach that combines these, and then use that to try and inspire us about what work we should do going forward, and some thoughts on how to empirically test scalable oversight approaches now using current LLMs. So maybe the kind of meta point to this is that I think the field of scalable oversight maybe needs some rejuvenation. It's perhaps fallen out of fashion a little bit. And so this talk is really trying to give a kind of positive case for why this is important and kind of, in my opinion, kind of unexplored, at least in the kind of new realm of empirical work we can do with LLMs. So this is the background section about the problem itself and some assumptions that we'll make. So the scalable oversight challenge. So the problem is we want accurate human oversight over superhuman AI, or it might be that we want our trusted proxies to have similar oversight levels. And there are two interrelated benefits that we can get from having scalable oversight. There are safety benefits, so we can use these during training, and the hope there is that this will lower our risk of reward hacking that can arise from models exploiting systematic oversight errors. So if we can reduce those errors and reduce the systematics, then hopefully we'll get less reward hacking and less misalignment as a result. So that's a thing you can use it for during training. During monitoring, you can also apply this to have weaker trusted models, which are equipped with the scalable oversight to help them monitor stronger untrusted models. The other benefits are of the usefulness variety. So if we can have scalable oversight, then we'd actually be able to widen the distribution of tasks that we can train on. This could go beyond automatically verifiable tasks. And in addition to unlocking more tasks that we can use, this may also have additional generalization benefits. So the kinds of assumptions that we'll need to make in order to make some progress on the problem are about continuity, continuous capability increase, and also continuous trust. So we assume with each generation of models that the capabilities will scale smoothly between them. That doesn't mean it will be slow necessarily, just continuous. And continuous trust as well. So with each successive model, there's no sudden change in our ability to determine whether we can trust the model or not. And there are various things apart from just scalable oversight that would enable this. Some of those that Neil was talking about in the previous talk. Okay, so here I'll give some background on what I think are some useful ingredients for scalable oversight. So these are not my ideas. These are ideas that are drawn together from the literature. So I think one key idea is around iteration. And so a good point in the space of literature here is recursive reward modeling. So the idea here is the top diagram. You have an outer loop in which you're using successive generations of models to assist the human in order in training the reward model for the next model. So each time the user is giving feedback for training their reward model, that human is able to query like previous generations of models. And the key insight here is that you can use successive generations of models to assist you to train the next generation. I think that is an idea that will stand the test of time. Decomposition is another area. So here I'm thinking around things at more of the flavor of debate and iterated amplification. And here the idea is that we're going to have some weak verifier trying to oversee strong provers, and this is kind of like a complexity theory angle on the kind of overall scalable oversight problem. And the idea is that you're going to try and come up with games which have incentives for the provers to check their own work or to check each other's work in order to aid the verifier in deciding what actually correct rewards will be. So the key insights here is that we want to try and decompose harder problems into simpler ones which are easier to verify and to aid in the efficiency of the supervision. And a third category of work which I think is important is that of legibility. So here the idea is that we want to come up with games in particular which incentivize clearer responses to be produced. Maybe that incurs some legibility tax. So these are the kind of 3 kind of buckets of ingredients. This is not exhaustive, but I think these are like useful areas to know about and to think about when you're trying to come up with an approach. Which is what I'm going to do next, is try and combine some of these into an example. This is not to say that this is definitely going to work, but I think there's enough ideas here for you to be able to put something quite sensible together. So the meta here is that we're kind of taking these existing good ideas and noticing that LLMs are only recently good enough to be able to empirically test whether combinations of these ideas actually work. So we're still early in investigating this kind of area of research. So the approach is basically the kitchen sink. We're going to combine the following. In the outer loop, we're going to do recursive reward modeling. We're going to use current generation model as the verifier for the next generation model. And then inside the inner loop, we don't just do kind of vanilla RL against the reward model. Instead, inside the inner loop, we do a few things. First, we make the reward model essentially more robust. And we can take some ideas from prove and verify games to try and improve the robustness of our verifier, which is of our current generation model, to then be able to train against that in a more robust way. Once we have that, then you can do something like debate to try and aid the verifier. And the variant of debate that you take might actually be quite simple. It need not necessarily be a 2-player game. You can actually take a single-player deterministic version of doubly efficient debate, so you can check out the reference for this. But the idea really here is that the debater can just try and decompose their response into separate simple parts, and then the judge should try and check every part in parallel. And the judge can do clever things like try and cross-examine the debater in this. You could also add a second debater for efficiency reasons, but to get it off the ground, that's perhaps a complication. You may want to just investigate this as it is. A third thing you can tack on as well is legibility training. So you can do something like tandem training, where you're at random points swapping out the stronger model and replacing it with the weaker model, and then only rewarding it if the stronger model can carry on kind of once it takes over control again. So you're trying to force it to be legible to the weaker one. So maybe the details of what's on the slide here are perhaps less important than the meta point, which is really that there are various combinations you can do of clever ideas that kind of, in theory, maybe sound quite good, and there's a very wide space of things that we could empirically test. We're still early. I think this also points to there being a shift in the human role compared to when some of these ideas were first investigated. So initially, the human role was going to be about doing high volume data labeling to try and improve our reward models. I think this changes now as models become stronger. Instead, humans are going to be doing more of auditing, changing the rules of the game and the principles for judgment, doing input curation, and actually being the thing that will be accelerated as a result of having these new tools. And in particular, we can try and apply that itself to also accelerate alignment research. And here I'm not talking about fully automated alignment research. I'm saying it should be accelerated by AI, ones that we can trust. I'm a little short of time, but I think my main point around doing empirical testing of this now is that you need not necessarily do full-scale human studies. You can actually get quite far by having weaker LLMs supervising stronger LLMs and trying to play around with these kind of all in simulation that way. And maybe later on you may go to looking at human studies. I'm out of time. So I'll leave up my slide here on takeaways, asks and offers. And my main offer is that if you're interested in these ideas, please do come and chat to me. Thank you.